Hello there. This is questions on magnetism that I don't know the answers to. So I'm going to try to start off with one magnet. I'm going to put my black cloth on it. It doesn't keep sticking to my fingernails. Okay. So when you look at one magnet, you see you get one vortex, and it's round, and it's in the middle. See it? It's in the middle, even though I'm not at 100% above this. I'm sort of at an angle. So that's what the standard one magnet is. Now, two magnets like that will give me not vortexes or whatever you want to call them in the middle, but you get them pushed out to the sides. Now, with two magnets together like that, both those poles, one's a negative and one's a positive, or a north and a positive, or a north and a south pole, you'd figure those would want to suck together instead of be pushed apart to the corners of the magnet. And I don't think it has to do with the other opposite poles, because if you use a long magnet that's two magnets long, it's closer together, left to right than it is long ways, unless there's some kind of weird field that goes right down the center and pushes them apart. But it sure looks like they're pushed apart. And on three magnets, you'll see that they will push the center one in. If I can get my cloth on here. So three magnets, and you see how it pushes it in to the center. Like not only are the outside ones pushed out to the edge, but the inside one is even squished further in. Now it's centered, but now it's squished into a cat eye. So why do these fields push against each other when they actually want to join each other? And if I do 4, so I'll take this off. So I'm going to do 4 magnets like that. And when I do that, you see that they're all pushed out to the corners with that structure that's joining them in the center, which actually creates a very tight spinning apparent vortex when I make a ferrophoto. Those things make very tight, sharp points that you can see in the ferrophotos if you look in my other movies. So why is it pointed out to the corners? When each corner attached to each other is opposite poles, you figure you want to squish in, and only the opposite corner poles are the same poles. So you got, like, north, south, north, south. So all the poles which you'd want to join, want to suck in, but they're all pushed out. And I don't think it has to do with the opposite corner poles being the same, because you see in the other two examples, it still wants to push out, even though the poles are, want to attract. So, I don't know. It's one of those questions that I have no clue about. But it is interesting nonetheless. Anyways, talk to you later.